Hey guys, I'm going to go ahead and get started with week 13 recitation. So define the following: oxidation, reduction, oxidizing agent, reducing agent. Oxidation, I always like to remember all of this, how I remember which one is which. Oil rig, oxidation is lose, reduction is gain. So oxidation is losing E minus, which means you're increasing the oxidation state. If you think about it, if you take away negative charges, it becomes more positive. So increase. Reduction. Our rig, reduction is gain. So reduction is gain E minus, and we are decreasing our oxidation state. Think about that. If you add electrons to something, it becomes more and more negative. It's decreasing. Oxidation agent is something that reduces, which is kind of backwards, but it's really not, because if you have an oxidizing agent, that means it's going to be oxidizing something else. So if it's an oxidizing agent, that means it's becoming reduced. So I might have said that wrong. So an oxidizing agent is oxidizes some other species. Well, the oxidizing agent itself becomes reduced. And similar thought, a reduction agent is going to reduce other species, which means that it becomes oxidized. So the oxidizing agent becomes reduced while the reducing agent becomes oxidized, which, again, that makes sense when you think about the oxidizing agent is oxidizing something else and the reduction agent is reducing something else. Okay, what is the oxidation number on the indicated atom in each of the following situations? Well, we remember when we have a lone atom or a diatomic molecule that's gaseous, we know the oxidation number is 0. So those first two are going to be 0. The carbon and CH4. So remember our other rule. We know that usually H plus is going to be positive unless it is part of a metal hydride, and an O minus, or an O, is going to be, let me rewrite that. H is equal to +1 unless it's in a metal hydride, and O is -2 unless it's in a peroxide. So the carbon in CH4, we know the H is +1 and the molecule is neutral, so that means the sum of the oxidation numbers is going to be 0. So the carbon has to be -4 because the hydrogen is +4, and +4 plus -4 is 0. Okay, carbon is, so in this case we have 3O2 minus, so we have -6 from the oxygen, but we know the molecule isn't 0 charge overall, it's -2, so plus the charge in carbon, we know carbon has to equal +4 in this case. So we have 0, 0, -4, and +4. Determine the oxidation number of elements in each of the following compounds. H2CO3, so again, we'll do the same thing. We know, we know that H is going to be equal to 1, right, because +1, because that's not a metal hydride. The O is going to be equal to -2, and then we figure out what the C is by adding up those oxidation numbers. So we have positive 2 minus 6, negative 4, so carbon has to be positive 4. N2, remember that's 0 because that is a diatomic molecule, a gas molecule, whatever you want to call it. ZnOH4, 2 minus, so oxygen, remember, is minus 2, hydrogen is positive 1, so that gives the overall molecule a charge of negative 1 times 4 is negative 4, and the overall molecule has a charge of negative 2, so the zinc is going to have a charge of positive 2. NO2, so the oxygen, remember, has a charge of negative 2, and the nitrogen has a charge of positive 4. LiH, so this is one of those metal hydrides, remember, so that means that the hydrogen is actually going to equal negative 1, which means the lithium is positive 1. Okay. Identify the species being oxidized, reduced, the oxidizing agent, and the reducing agent in each of the following reactions. Okay, so to go from Cr plus to Cr3 plus, we are losing 2E minus, right? Which means, remember our oil rig, oxidation is lose, reduction is gain. Since we're losing electrons, it's oxidation, which makes it a reducing agent. Which makes Cr plus a reducing agent. Then we'll go on to our Sn. Sn4 plus goes to Sn2 plus, and it is, let's see, it is gaining electrons because it's becoming less positive, which means it's being reduced. Remember, reduction is gain. And since it's becoming reduced, it is the oxidizing agent. Then we'll go on. 3Hg2 plus goes to 3Hg2. So, let's see. So 2 plus, it is gaining no, it is losing electrons because it is it gaining or losing? Let's see. 2 plus 2E minus goes to, yeah, so it's gaining electrons, making it reduced. Reduction is gain. And it is an oxidizing agent because it's getting reduced. It's oxidizing something else. And then we will have our Fe2 plus becomes more, it's losing E minus, right? It's becoming more positive. So it's becoming oxidized, making it a reducing agent. And then we are going to go on to the last one. So AS. Oh, I didn't. So this one, our AS, we can see it is being oxidized because the oxidation number goes down. Right, it goes from, well, Cl minus we know has a -1 oxidation number. So that means it has to have a positive. So it goes from 0 to a positive number. So it's losing electrons, making it oxidized, and the reducing agent. And then we know that chloride, remember, it has the -1, so that means it's gained electrons, making it reduced. Reduction is gain, our oil rig, and then the oxidizing agent. Okay. Iron metal oxidizers in the presence of O2 to form iron oxide. Would you expect iron and iron oxide to have a higher or lower oxidation number? than metal. Why? Okay, so if it's becoming oxidized, then you would expect a higher oxidation number, since oxidation is the loss of E minus. You're going to have an increased oxidation state because it is more positive. It becomes more positive. You can also just look at it and calculate it out. So Fe has an oxidation state of 0, and Fe2O3 minus, the Fe is going to have an oxidation state of -3, right? It goes, because the oxygen is -2 times 3, and you have to divide that by 2, is a -3. Sorry, a +3. It's a +3 because oxygen is negative, so iron is a positive, which means it has a higher oxidation state, right? It became more positive. Okay, based on the following reaction, is copper or zinc a stronger oxidizing agent? And we're saying that this reaction occurs spontaneously. So that reaction they've shown us is spontaneous. So we have copper on the left side and zinc on the right side. Since the reaction is spontaneous, it's going to be Cu2+, that is the stronger oxidizing agent, since the forward reaction occurs spontaneously. Remember, with redox reaction, is either one way or the other. It's going to occur spontaneously, so you just have to figure out which way. Basically, if it's not spontaneous in one direction, it will be spontaneous in the other direction, and whichever direction it's spontaneous in has the stronger oxidizing agent. Okay, I'm gonna pause this and we'll go to the next thing in a new video.